Why do horses sleep standing up?
Almost all horses sleep standing up because of the unique way they are built. The bones and ligaments, elastic bands that connect bones at joints, in a horse's legs lock together in a unique way, allowing its muscles to become completely relaxed while it remains standing. So the weight of a horse's body is safely suspended on its specially locked legs while it sleeps. Lying down while sleeping probably wouldn't be comfortable for a horse anyway. Horses are heavy animals with big muscles, but their bones are surprisingly delicate. Lying in one position for a long time could very likely injure a horse. Scientists think that horses developed their habit of sleeping upright as a defense mechanism, a way of protecting themselves against predators. Their speed is their main defense in the wild. And a standing position keeps a horse in a constant state of readiness to race away if danger should approach. Rising from a laying position takes the leggy beasts more time than most animals.
What are the continents?
The land masses on Earth are divided into 7 continents. They are, from largest to smallest, Asia, Africa, North America, South America, Europe, Antarctica, and Australia. Some people group Europe and Asia together into a single continent called Eurasia. At 17,226,000 square miles, 44,614,000 square kilometers. Asia covers about 30% of the world's area. Australia, at the other end of the size spectrum, is 3 million square miles, 8 million square kilometers. Australia is not only a continent, it's a country, too. And while it ranks as the smallest continent, Australia is one of the largest countries in the world.
What is the smallest bone in my body?
The smallest bone in your body is the stirrup, located in the middle ear. It is about the size of a grain of rice. It is named that because it looks just like a tiny stirrup. The part on a horse's saddle on which you rest your foot. When sound waves enter your ear canal, they vibrate your eardrum. The 3 tiny bones behind it also vibrate, increasing the strength of the sound as it passes through the middle ear. The stirrup, along with the hammer and the anvil bones, also named for their shapes, transfer their vibrations to the inner ear, where they become nerve impulses and travel to your brain.
What is acid rain?
Some of the gases released as waste products from factories, cars, and power plants mix with water vapor in the atmosphere to produce acid rain, or sleet or snow. Rain is slightly acidic anyway, but when mixed with such chemicals as sulfuric acid and nitric acid, it can reach dangerous levels. Acid rain can damage soil, crops, and forests as well as eat away at the outer surfaces of buildings. In some places, acid rain that has fallen into lakes and rivers has caused severe harm to the animals and plants living there. Acid rain has affected many parts of the United States and Canada, as well as countries in Northern and Western Europe and parts of Asia. Because the wind can carry pollutants great distances from their source, many areas have suffered devastating effects of acid rain without being responsible for the chemical waste that caused it.
What is a Cayman?
A cayman, also spelled Cayman, is a close relative of the alligator that can be found in Central and South America. Like their crocodilian cousins, caymans live near rivers and other bodies of water. Most caymans are around 6 or 7 feet, 2 meters, long, but the largest species, the black cayman, can grow to a length of 15 feet, 4.5 meters.
What is static electricity?
All matter is made of tiny particles called atoms. Inside an atom are even tinier particles, electrons that move in orbit around a center, or nucleus, made of neutrons and protons. An electron has a negative electric charge and a proton has a positive one. Usually an atom has the same number of each, which keeps the atom neutral or unchanged arged. But sometimes electrons leave their orbit, attracted to other atoms that lack an electron and are positively charged. The movement or flow of electrons from one atom to another produces the form of energy called electricity. When electrons are moved by a force through a conductor like a wire, the flow of energy they create is known as current electricity. The work that this form of electricity does can be seen when we turn on a light bulb or watch a television show. Static electricity is a form of electricity that does not flow, it is electricity at rest. Objects carry positive electric charges when some of their atoms have fewer electrons than they should, and they carry negative electric charges when some of the atoms have more electrons than they should. An easy way to produce static electricity is to rub two objects, made of certain materials, together. This transfers electrons from one item to another, giving each a positive or negative charge. Positively and negatively charged objects are attracted to each other like magnets because each wants to shed or acquire electrons. When static electricity becomes powerful enough, so many electrons jump from one thing to another that they cause a visible electric spark, which you will feel as a little shock if one of the things the electrons jump to is you. Loose electrons can attach to atoms in the surface of your skin. Lightning, in fact, is really just a giant spark that results when static electricity builds up in a cloud during a thunderstorm.
What are some of the different energy sources?
The main energy sources used around the world today are oil, coal, and natural gas. These sources of energy are called fossil fuels, so named because they come from the fossilized remains of plants and animals that lived hundreds of millions of years ago. Coal, for example, comes from fossilized plants and trees. A long time ago, as plants and trees died, their remains became buried under the weight of layers of mud or new plants, and they eventually turned into stone. That stone can be cut out from deep, underground coal mines and burned for energy. Fossil fuels are used primarily for transportation: airplanes, cars, trains, and so on, and for heating and cooling houses and other kinds of buildings. Fossil fuels provide a large percentage of the energy consumed around the world. But they are non-renewable resources, meaning that there is a limited amount of each of these types of fuel. And when they are gone, no more can be produced. Because there is a limited supply of fossil fuels, scientists are continuously exploring other sources of energy that have an unlimited supply. These renewable energy sources are cleaner and have much less of an impact on the environment than non-renewable sources like fossil fuels. Such sources include the sun, solar power, water, hydropower, and wind. The heat of the sun can be captured with solar panels and used to heat homes and offices. It can also generate electricity, which can then be used for a variety of purposes. Flowing water can also produce energy. Usually hydropower plants use a dam on a river to collect water in a reservoir, or large pool. When that water is released to flow downward, it passes through a device called a turbine, which has blades like a giant fan. The force of the water spins the turbine, which then activates a generator, which produces electricity. Turbines are also used to convert the power of wind into electricity. These turbines, with blades like a propeller, are mounted on a tall tower. The wind spins the blades, and, as with hydropower, the spinning of the turbine causes a generator to produce electrical power. Another renewable energy source is called geothermal energy, which uses the heat from just below Earth's surface. This heat can be converted into electricity or used to directly provide heat for buildings. There are many advantages to renewable energy sources, but scientists have yet to solve problems associated with producing these kinds of energy inexpensively and transporting that energy to distant areas. Another important energy source is nuclear energy. Nuclear energy comes from either splitting the nucleus of an atom, called nuclear fission, or combining atomic nuclei, called nuclear fusion. The nuclear energy produced today comes from fission. The process of splitting atoms produces a massive amount of energy that can be used in many different ways. But nuclear fission has some serious disadvantages. The process creates large quantities of hot water that must be cooled. Using expensive machines, before being dumped into lakes or rivers. If water is dumped while still hot, it can cause something called thermal pollution. The hot wastewater raises the temperature of a body of water, disrupting the balance of life in that water and even killing some fish and other creatures. Nuclear fission also produces radioactive waste, which is dangerous to the environment and must be stored safely for long periods of time. The threat of an accident involving a leak of radioactive material is always present at a nuclear power plant.
How do submarine pilots know where they are going when they are underwater?
If they are not too far below the surface, a periscope is used. This tall, rotating, tube-shaped instrument can be raised above the water's surface to view surroundings. Using a series of mirrors and lenses inside to relay images. Beyond that, submarines use sonar, sound waves, to make echo soundings of their surroundings. Transmitted sound waves are reflected off objects or the ocean floor. The time it takes for these sound waves to be reflected back indicates how far away things are located. The echoes are then converted into electrical signals that appear on a display screen, which gives a picture similar to that of an airport's radar screen of surrounding waters.
Why do we have different time zones throughout the world?
At one time, every region of the world had its own system for measuring time. Traveling from one locality to another could be very confusing. Adding to the confusion is the fact that, even if every place measured time in the same way with each day being 24 hours, each hour being 60 minutes, etc., the fact that Earth is constantly rotating means that when it's midday in Chicago, Illinois, it's early evening in London, England. The rotation of the planet means that we can't have just one time zone for the whole world. If that were the case, then noon would be the middle of the day in some places, the evening in other places, and the middle of the night somewhere else. In some places, the sun would go down at 7 p.m. But that same hour thousands of miles to the east would be the time the sun was rising. In the late 1800s, participants at an international conference figured out a way to divide the world into different time zones to account for Earth's movements. In one day, Earth makes one rotation on its axis. It moves 15 degrees every hour, so after 24 hours it has come full circle, or 360 degrees. Scientists therefore decided to divide the planet into 24 sections of 15 degrees each. They used the imaginary longitudinal lines, called meridians, that run between the north and south poles. The starting point is a place called Greenwich, a London suburb. The line running through Greenwich is called the prime meridian. Every 15 degrees to the west of Greenwich is another hour earlier than what is known as Greenwich Mean Time, or GMT, and every 15 degrees to the east is another hour later. So if it is noon in Greenwich, in one time zone to the west it is 11 a.m. and in one time zone to the east it is 1 p.m., while the longitudinal lines are straight and fixed. The lines dividing actual time zones have been changed a bit to accommodate the people who live there.
What is the order of the planets in our solar system?
Starting with that closest to the Sun, the order of the planets is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. If you have trouble keeping track of this order, remember this sentence, in which the first letter of each word is also the first letter of a planet. My very educated mother just served us 9 pizzas.
Which animal has the longest life?
The animal believed to have had the longest lifespan ever recorded was a Marian's tortoise that lived over 152 years. Several other types of tortoises have been known to live longer than 115 years. Clams also tend to live a very long time, with a quahog, pronounced quahog, living around 150 years and a deep-sea clam living around 100 years. The oldest person on record lived 122 years.
How do computers work?
A computer, like all digital machines, changes writing, images, and sound into a special numerical language. It is a binary, or two-part, language that has just 2 number pairs, 0 and 1. These numbers are called binary digits, or bits for short. In a digital machine, the numbers take the form of electric signals. With a 1 the electricity is switched on and with a 0 it is switched off. Information of all kinds, then, is turned into electrical on-off signals arranged in countless individual patterns. These patterns can be stored, sent along digital pathways, or converted back into forms that we can use and understand with extraordinary speed and accuracy. Bits enter a personal computer from the keypad, mouse, microphone, and scanner. They are received and sent out by the modem, as well as stored in various memory devices. The computer screen, printer, and speakers convert the bits into forms of information that we can use.
Do all children go to school?
A lot of children around the world learn to read and write and do arithmetic in places that don't resemble the school that you go to. A temple, a tent, or a building on stilts may serve as a classroom. For some children living in very different places around the world. In poor places that have no money to build schools, children may learn their lessons outdoors. In isolated places like the Australian outback or Alaskan wilderness where families live hundreds of miles apart and far from cities and towns, children may get their lessons from teachers over two-way radios or, in recent years, over the internet. And not all children go to school as we know it, learning lessons from a teacher. Reading, writing, and arithmetic may not be important skills for some children to learn. A child living in the bush in Africa, for instance, may have little use for mathematics, but will need to know how to identify animals' tracks and make bows and arrows for hunting. Parents or other adults will train the child until the skills are learned, acting as teachers. So while not all children learn what they need to in a typical classroom, most learn the skills that are important to their way of life. Children learn all sorts of things inside and outside classrooms.
How big is the sun?
The sun's diameter, its widest measurement across, is estimated at 865,400 miles, 1,393,294 kilometers. Its mass is 332,000 times that of Earth. Compared with the billions of stars in the universe, our sun is considered average in size, with half of the other stars bigger and half smaller.
Where does dirt come from?
Dirt, or more accurately, soil, is the surface layer of Earth in which plants can grow. It can be a few inches deep or extend down for several feet. It is made up of tiny pieces of rock of various sizes and shapes, along with air, water, and humus, which is the decomposed remains of plants. The more humus soil contains, the better it can hold the nutrients and water that plants need to grow. The different types of rocks that make up soil are usually fine particles of parent rocks that lie farther below Earth's surface. These have been made fine by erosion worn by wind and water, or by geological occurrences like volcanic eruptions and the movement of glaciers. There are many kinds of rocks composed of different minerals and formed in different ways that make up Earth's crust.
Why do raccoons wash their food before they eat?
Raccoons have small, slender feet that they use to catch and hold onto their food. Their front feet resemble little hands. And their slender fingers can be used to remove garbage can lids and open containers and even door latches. Raccoons in the wild have often been observed swishing their food through the water of a lake or stream before eating, giving the appearance of washing their food and their hands. Raccoons kept in cages will also wet their food, dipping it into their water bowls. Scientists are not sure why raccoons exhibit this behavior. At one time they believed raccoons did not have enough saliva and needed to moisten their food before swallowing it. They now know that isn't true. Some believe raccoons might wet their food so they can mush it up a bit to make sure they've removed any sharp sticks or bones. Some have speculated that raccoons have a highly developed sense of touch, and they just like to handle their food in many different ways, putting it in water, rubbing dirt on it to figure out what it is they are eating. Sometimes raccoons have been seen washing food in dirt instead of water, which indicates that this is an instinctive behavior that may not have any purpose at all.
What can we do to protect ourselves if a tornado comes?
Only between 700 and 800 tornadoes occur in the United States each year. And of those, only between 1 and 2% cause deaths. Communities watch for tornadoes when weather conditions are right and issue warnings to alert people if a tornado has been spotted in the area. In addition to warnings being broadcast on the radio and television, many communities have tornado sirens that can be heard for many miles, signaling that a tornado has been spotted and people should take cover. The best place to be during a tornado is under the ground, in a storm cellar or basement of a building. Take a radio with you, so that you can keep track of the storm. A flashlight will help you to see if the electricity goes out. And a first aid kit can help treat any minor injuries that might occur. If you can't go underground, go to an inside room on the lowest floor of a building. Hallways are good places to go, as are bathrooms. The plumbing and pipes in them are strong and could resist violent winds. Get under a stairwell or sturdy piece of furniture, if you can, which will protect you from falling objects. Avoid being near windows. Many tornado injuries are caused by flying debris and sharp objects, like pieces of broken glass, are very dangerous. If you are outside, try to lay as low as possible on the ground in a ditch, valley, or under a strong bridge. Protect your head with your hands. Don't seek shelter in something that can be lifted into the air by a tornado, like a car or mobile home.
What causes a yawn?
When you are bored or tired, you sometimes give a big yawn. Yawning happens because you are not breathing deeply enough. Oxygen, the gas needed to run body processes, and carbon dioxide, the waste gas produced by these processes, Travel in your bloodstream and enter and exit your body through your lungs. When you don't breathe deeply enough, too much carbon dioxide builds up in your body and your brain gets the message, telling you to breathe more deeply to fix the problem. A yawn is a great big breath that clears carbon dioxide from your lungs and forces you to take in fresh, oxygen-rich air. Sometimes a series of yawns is required. Scientists don't know why yawning seems to be contagious. But it usually is. When one person yawns, others often start yawning, too.
Why do my lips turn blue when I'm in cold water too long?
Your red, fleshy lips are full of blood vessels. When you are in cold surroundings, the blood vessels in your skin become narrower. This narrowing reduces the amount of heat lost through your skin and channels more blood to the internal organs that run your body. When the blood vessels in your skin contract, it loses its usual pinkish color, a color that comes from the regular supply of red blood flowing through it, and you appear pale. Your lips lose their rosy color, too. You resemble a person who has cyanosis, a condition caused by a lack of oxygen in the blood that makes the lips and skin appear blue or gray. Even though you have enough oxygen in your blood when you are in cold water, most of that blood is directed inward. After you leave the water and warm up, your blood begins to circulate normally through your skin again, and your red lip color returns.
Why do I sweat when I'm hot?
When you get hot, your body has a couple of ways to cool down. The blood vessels in your skin expand, allowing more blood to flow through them. The heat the blood carries then escapes through your skin. When you are hot, you also produce more sweat, or perspiration, fluid made in sweat glands, millions of them, that cover your body, located deep in your skin. Sweat carries body heat to the surface of your skin through pores, or tiny holes, where the moisture evaporates into the air and cools you off. When you sweat faster than it can evaporate, you can get pretty soggy. It is important to remember to drink plenty of water when you are doing a lot of sweating so that you don't dehydrate, or lose bodily fluids. About 62% of a person's body weight is water. A lot of fluid is necessary to keep body processes running smoothly. Under extremely hot conditions, a person can lose up to 20 quarts of perspiration a day, which can lead to serious health problems if those fluids aren't replaced. You've probably noticed that your body doesn't do much to cool you off on very humid, sticky days. Sweat needs to evaporate, or turn into water vapor, in order to make you feel cooler. But on humid days, the air has so much water vapor in it already that it can't hold any more. when the air is nearly saturated like that. The sweat on your skin cannot evaporate fast enough to give you any relief. Sweat will evaporate better off your skin if you wear cotton clothing, which lets your skin breathe, rather than synthetic fibers like nylon, spandex, or polyester.
What are wisdom teeth?
Your 4 wisdom teeth are the last of your permanent teeth to appear. These molars, located at the back of the jaw, come in between the ages of 17 and 21. They emerge around adulthood along with the wisdom that supposedly comes with maturity, which explains their name. In a lot of people, though, one or more of these teeth never come up. Usually because there is not enough room on the jawbone. Long ago, primitive people had longer jaws that held these extra molars that were so important for chewing the tough meat that made up most of their diets. But as prehistoric men and women evolved and their brains became larger, the shape of their skulls changed, too, which included a shortening of the jawbone. So now we have an extra set of teeth not essential for our refined diets. And we have very little room in which to grow them. Wisdom teeth can cause problems whether above or below the gum surface. They can be difficult to keep clean and sometimes cause infections. Many people have their wisdom teeth removed before such problems occur.
Why are most big cities located near water?
Most large cities got their starts in the days before trains, airplanes, or cars. Land travel back then consisted of riding horses, bumping along rough roads in animal-drawn wagons or carriages, or making one's way by foot. In those days, the easiest way to travel long distances was by ship. So towns with good harbors that were located on oceans, lakes, and rivers became gathering places. Travelers got on and off ships there, sometimes bringing goods from faraway places, called importing. Such towns became trading centers, developing their own businesses to make goods to ship away, or export. Workers moved into these towns to fill the growing numbers of jobs. And others came to provide services for the increasing populations, building lodging, banks, and stores. Being located near water allowed many towns to prosper, growing into cities.
Why don't dogs get hoarse when they bark a lot?
It seems like some dogs can bark and bark for hours. Yet they never seem to get hoarse or lose their voice. Bark, like people do when they talk, yell, or sing too much. Veterinarians, animal doctors, think that is because a dog's voice box, or larynx, is not as complicated as the larynx of a human, who needs to make a wide range of different sounds to speak. So the stress that results from excessive barking doesn't do nearly as much damage as overusing a human voice does.
What better reason could you have for taking good care of the library materials that you use?
It makes sense to treat them with the same respect that you would your own possessions or those of a friend. It's also important to return borrowed library material on time, so that another library user can have his or her turn using it.
Why do I have to brush and floss my teeth?
Brushing and flossing your teeth is critical to keeping them healthy and free from decay. With good dental habits, you can have your teeth for a lifetime. Because your mouth is dark, wet, and warm, it is a perfect place for germs like bacteria to grow, feeding on bits of old food. Removing food from your teeth after eating is a good way to limit the amount of tooth-damaging germs in your mouth. Because most food particles stick between your teeth and at the spot where your gums and teeth meet. Keeping those places clean is especially important. Just scrubbing with a toothbrush usually can't do this, so dental floss should be used, too. When bacteria break down certain foods in your mouth, they form an acid that dissolves the hard outer covering, enamel, of teeth. Over time a small hole, or cavity, may form on a tooth, allowing bacteria to travel farther inside. A dentist usually uses a filling made of metal or plastic to fill in the cavity and stop the decay. But if not caught and treated early, decay may spread, reaching tooth roots and nerves and causing pain and infection. When a tooth becomes too damaged, it may fall out or a dentist may have to remove it.
Why do we measure things differently than most people in the world?
Different systems of measurement are used in the world today, with the two most important being the metric system, or International System of Units, SI, and the English units of measurements. From ancient times, people have always used various units to measure the weight, volume, and length of things. A certain number of plant seeds might make up a unit that measured weight, for instance, and then that unit could be used to measure other things besides seeds. The measurement of a body part might have been used to create a unit that showed length. The length of an inch, for example, came from either the width of a man's thumb or the distance from the tip of a man's finger to the first joint. The yard came from the length of a man's arm from nose to finger to pan, the foot from the size of a man's foot. But until these units were standardized, with a set unit of weight or length agreed upon, measurement was unreliable, because seeds and people come in all sizes. As late as the 18th century, the same measurement units varied from place to place. but French scientists began a movement around that time to have a single, precise measurement system used by all countries throughout the world. They called it the International System of Units, and it is based on the metric system, where all measurement units are multiples of 10. The meter is the standard unit of length, and the kilogram is the standard unit of mass, or weight. Bit by bit, this system of measurement was officially adopted for use by all the countries of the world, except for the nations of Liberia, Myanmar, also known as Burma, and the United States. Many people believe the United States should switch to the metric system. But the complicated process of changing from one measurement system to another usually takes a number of years. In the United States, most people still use an older and more complicated measurement system called the English units of measurements. That standard unit of length is the yard and the pound is the standard unit of mass, or weight. Measurements can be changed from one system to another using mathematical equations or a conversion chart. While the metric system is being used more and more in the United States, particularly in the scientific community, there has still been no official move to adopt it.
Why do I have to eat?
Food and drink provide the energy that your body needs to function and the materials required for growth and repair. People can't live without food and drink for very long. A healthy diet requires a certain amount of 6 different substances: proteins, carbohydrates, fats, fiber, vitamins, and minerals. In addition, water is required to keep body processes running smoothly. Proteins, found in meat, fish, eggs, dairy products, peas, beans, and grains, are required for the repair, replacement, and growth of body tissue. Carbohydrates, found in bread, pasta, potatoes, and cereals, are good sources of quick energy for the body. Fats, found in many animal and plant foods, like meat, eggs, and nuts, also provide the body with energy and are sometimes used for growth and repair. Vitamins are chemicals that the body needs to function well. Minerals are metals and salts that the body also needs in tiny amounts to run. Different foods, like vegetables, contain different amounts of vitamins and minerals. So it is important to have variety in your diet so you can get a good balance. Fiber or roughage, parts of plant foods that the body can't digest, is important for the proper working of the digestive system. It provides the bulk that digestive muscles need to grip onto as they push food along and carry away body waste. Water is also a very important part of a healthy diet. An adult's body loses about 4 pints, 2 liters, of water every day through urine, bowel movements, sweat, and the moisture in exhaled breath. Those fluids need to be replaced by drinking water, or other healthy beverages, and eating food, Water makes up about 70% of the food we eat. An individual can survive weeks without food but only 4 or 5 days without vital water.
When I take medicine for a headache, how does it know where to go?
When you have a headache or a toothache or any other kind of ache, you take a pain reliever like aspirin, and a few minutes later, the pain is gone.
What does alcohol do?
A short while after a person takes a drink of beer, wine, or liquor, the alcohol in that drink will be absorbed into the bloodstream and transported to the brain and the rest of the body. The rate at which that happens depends on the person's size. The concentration of alcohol in the drinks, and how much food is in his or her stomach. Alcohol interferes with the messages normally passed from nerve cells to the rest of the body. A drunk person can't hear, see, smell, taste, or feel as well as a sober person, and drunk people are less sensitive to pain. Alcohol is a depressant, which means it slows down brain function. That slowing gives people a relaxed feeling. But it also means that the senses are dulled and reaction time is slower. With alcohol in their blood, people are less coordinated and lose some control over their muscles. Many drunk people have trouble walking without staggering. A particularly dangerous effect of alcohol is the resulting lack of inhibitions or inner restrictions over behavior. While most people wouldn't drive into oncoming traffic while sober, it might seem like a fun thing to do when drunk. People are more likely to get into fights, drive dangerously, and generally put themselves into risky situations when they are drunk. And because alcohol is a depressant, it will only increase the feelings of sadness or loneliness that drive some people to drink in the first place. For people under the legal drinking age, 21 in the United States, alcohol can also cause problems with the police. Anyone under age 21 caught with alcohol or under the influence of alcohol can face legal penalties.
Should I pop a blister?
Just like scabs, blisters appear for good reasons. When skin is injured by burns or irritating chemicals, like poison ivy, or friction from the repeated rubbing of stiff new shoes on your feet, for instance, your body produces a cushion of fluid under the damaged area to protect the new skin cells that are growing below to repair the spot. So popping or removing a blister takes this protective covering away. It is better to leave a blister alone and keep the damaged skin clean. A band-aid can be used to cushion the spot. A blister may break on its own, if not The fluid will be absorbed back into the body once it's no longer needed.
What is the sun?
The sun is a star, just like the twinkling heavenly bodies we see at night, far off in the dark sky. But the sun looks different to us because our planet is quite close to it. Just 93 million miles 150 million kilometers away. The sun. A sphere or ball made of several layers of gases, gives off tremendous heat and light. It takes about 8 minutes for the sun's rays to cross space and reach Earth. It is believed that the sun's vast and continuous production of energy is due to nuclear reactions among the atomic particles of hydrogen, one of its gases. The sun is the center of our solar system, and its gravitational attraction keeps Earth and its neighboring planets in their orbits. The sun's energy is responsible for Earth's weather. Solar heating causes air to move, wind, and also causes rain by contributing to evaporation, a key step in our planet's water cycle. Without solar heat and light, plants could not grow and animal life could not survive on Earth.
How can snakes swallow animals larger than their own bodies?
Snakes do not always eat animals whose bodies are wider than their own, but they are certainly capable of it. And because they swallow their prey whole without bothering to chew it up first, they need to be equipped with special characteristics for getting food to their stomachs. First of all, snakes have unique jaws. The lower jawbone is only loosely connected to the upper jaw, and the lower jaw is made up of two bones that are connected by an elastic, or stretchy, tissue. So the snake can open its mouth very wide, several times as big as its own head, accommodating a relatively large animal. Also, the two sides of a snake's jaw move separately from one another. The snake sinks its fangs, which are curved backward, into its prey. It moves first one side of the jaw backward and then the next, gradually pulling the prey into its mouth. It can take a snake 30 minutes to an hour to swallow an animal. During that time, its trachea, or windpipe, gets pushed forward, out of its mouth. So the snake can continue to breathe during the long swallowing process. The snake's flexible ribs then expand to allow the body to widen as the food makes its way to the stomach and intestines. Given that eating is such a time-consuming and body-expanding process, it is perhaps fortunate that a snake doesn't need to eat very often. Snakes may eat once a week or once a month. And some large snakes in captivity have been known to go several months between meals. During colder seasons, snakes are dormant or inactive and can go much longer than usual without eating.
Why are there zoos?
Zoological gardens, commonly known as zoos, were created for a number of reasons. Since ancient times, people have captured wild animals for collections. For the pleasure of owning and observing them, and in order to learn more about them and their habits. Very few people can travel to the wilds of Africa and other exotic places. But by visiting a zoo they can see firsthand some of the world's huge variety of creatures. Today, most large cities have zoos. People can learn more about animals there and about how to protect the native habitats from which these creatures come. Many zoos are havens where endangered animals can live protected and where there are breeding programs that try to increase the population of such creatures to keep them from extinction. Zoos also provide homes for animals that have been injured and could no longer survive in the wild. Zoos both entertain and educate those who visit them.
What is ozone?
Ozone is a sharp-smelling gas that is a form of oxygen. There is a layer of ozone in the upper atmosphere, about 15 miles, 25 kilometers, above Earth. That layer helps protect us from the harmful ultraviolet rays of the sun. Without the ozone layer, too many of those rays would get through, making it difficult for plants and animals to live. During the 1970s, scientists became aware that certain chemicals, called chlorofluorocarbons, or CFCs, were making the ozone layer thin and even causing some holes. CFCs were used in aerosol cans, air conditioners, and refrigerators. By the mid-1990s, the United States and many other countries had banned the use of CFCs. Ozone also exists in the lower atmosphere. But while the ozone in the upper atmosphere is beneficial, that in the lower atmosphere causes air pollution. When sunlight interacts with the fumes from cars and trucks, ozone is the main ingredient of the smog that is produced. In large amounts, ozone can cause headaches, itchy eyes, and lung problems in people. It can also harm other animals and plants. And it damages rubber tires and the outside surfaces of buildings.
What are eating disorders?
Eating disorders are psychological, or mental ailments that involve an obsession with food and with being thin. Eating disorders strike about 1% of teenagers in the United States. And girls are affected far more often than boys. People with eating disorders frequently feel depressed and anxious. And they often have a low opinion of themselves. They develop an obsession with food and sometimes devote many hours a day to an intense exercise routine. They frequently withdraw from friends and family, finding excuses to avoid social situations, particularly those that involve food. The two most common eating disorders are anorexia and bulimia. People suffering from anorexia avoid eating whenever possible. What little food they do eat causes anxiety and fear that it will make them fat. Anorexic people usually lose weight rapidly. But even after they've become alarmingly skinny, they still look in the mirror and see themselves as overweight. Anorexia can cause a severe drop in energy and ability to concentrate. It can also result in damage to internal organs, loss of hair, and weakening of bones. If it goes untreated, anorexia can become quite serious and even deadly. Bulimia is characterized by behavior known as binge and purge. People suffering from this disorder eat large quantities of food, but as soon as they've finished eating they make themselves throw up or take laxatives, which stimulates the colon to produce a bowel movement. Bulimia can cause damage to the kidneys and stomach. And the frequent vomiting sometimes causes the person's tooth enamel to decay. People with anorexia often appear dramatically thinner. But bulimia can be harder to recognize, as a bulimic person does not actually lose much weight. Doctors aren't exactly sure what causes eating disorders. Some believe they are a result of the tremendous pressure society places on young girls to be thin models. In magazines and celebrities on television reinforce the idea that being beautiful equals being thin. Some research has suggested that eating disorders may be the result of a chemical imbalance in the brain, and that the tendency to develop such a disorder can run in families. Regardless of the cause, it's vitally important that people with eating disorders seek treatment. Eating disorders can be very serious, and the longer they go on, the harder it becomes to treat them.
What are some of the different energy sources?
The main energy sources used around the world today are oil, coal, and natural gas. These sources of energy are called fossil fuels, so named because they come from the fossilized remains of plants and animals that lived hundreds of millions of years ago. Coal, for example, comes from fossilized plants and trees. A long time ago, as plants and trees died, their remains became buried under the weight of layers of mud or new plants, and they eventually turned into stone. That stone can be cut out from deep, underground coal mines and burned for energy. Fossil fuels are used primarily for transportation: airplanes, cars, trains, and so on, and for heating and cooling houses and other kinds of buildings. Fossil fuels provide a large percentage of the energy consumed around the world. But they are non-renewable resources, meaning that there is a limited amount of each of these types of fuel. And when they are gone, no more can be produced. Because there is a limited supply of fossil fuels, scientists are continuously exploring other sources of energy that have an unlimited supply. These renewable energy sources are cleaner and have much less of an impact on the environment than non-renewable sources like fossil fuels. Such sources include the sun, solar power, water, hydropower, and wind. The heat of the sun can be captured with solar panels and used to heat homes and offices. It can also generate electricity, which can then be used for a variety of purposes. Flowing water can also produce energy. Usually hydropower plants use a dam on a river to collect water in a reservoir, or large pool. When that water is released to flow downward, it passes through a device called a turbine, which has blades like a giant fan. The force of the water spins the turbine, which then activates a generator, which produces electricity. Turbines are also used to convert the power of wind into electricity. These turbines, with blades like a propeller, are mounted on a tall tower. The wind spins the blades, and, as with hydropower, the spinning of the turbine causes a generator to produce electrical power. Another renewable energy source is called geothermal energy, which uses the heat from just below Earth's surface. This heat can be converted into electricity or used to directly provide heat for buildings. There are many advantages to renewable energy sources, but scientists have yet to solve problems associated with producing these kinds of energy inexpensively and transporting that energy to distant areas. Another important energy source is nuclear energy. Nuclear energy comes from either splitting the nucleus of an atom, called nuclear fission, or combining atomic nuclei, called nuclear fusion. The nuclear energy produced today comes from fission. The process of splitting atoms produces a massive amount of energy that can be used in many different ways. But nuclear fission has some serious disadvantages. The process creates large quantities of hot water that must be cooled. Using expensive machines, before being dumped into lakes or rivers. If water is dumped while still hot, it can cause something called thermal pollution. The hot wastewater raises the temperature of a body of water, disrupting the balance of life in that water and even killing some fish and other creatures. Nuclear fission also produces radioactive waste, which is dangerous to the environment and must be stored safely for long periods of time. The threat of an accident involving a leak of radioactive material is always present at a nuclear power plant.
Why do my ears pop when I'm traveling in an airplane?
Your eardrum is a thin, stretched membrane that separates your outer and middle ear. When sound waves hit it, it vibrates, just like the head of a drum. Your eardrum transfers sound vibrations to tiny bones in your middle ear, whose own vibrations increase the strength of the sound. The eustachian tube, which connects your middle ear with your throat, is responsible for keeping the air pressure in the back of your eardrum in the middle ear the same as it is in front of it. If air pressure is less behind your eardrums than in front, they are stretched backward and cannot do their job as well. Your ears feel blocked or stuffy and sometimes even hurt. This pressure change happens when you move quickly between high and low places, like in an airplane. Sometimes swallowing hard or yawning can stretch open the eustachian tube, forcing more air into your middle ear. Your ears will pop, then, which is a sign that air pressure is equalized in your ear and that your eardrums have snapped back into place. After your ears pop, you should be able to hear normally.
Why is there wax in my ears?
Located in the 1-inch passageway, or canal, of your outer ear are 4,000 special glands that make wax. Because it's sticky, earwax catches dust, dirt, and other things before they can travel farther into the ear. As you chew and talk, the muscles of your face move the lining of the ear canal. And old wax eventually works its way out of the ear. It is not a good idea to clean your ears with a stick or swab, because that can push earwax against the eardrum and cause damage. A few people produce too much earwax, which causes blockages that reduce hearing. When this happens, a doctor should remove it.
Why do people sweat when they're nervous?
Feelings of nervousness or excitement trigger certain responses in your nervous system, including the production of certain hormones that activate sweat glands. The sweat glands most likely to respond to such hormones are those in your armpits and the palms of your hands. Many people refer to sweating in these conditions as breaking out in a cold sweat.
How much of Earth's surface is covered by water?
About 71% of Earth's surface is covered by water. 3% of this supply consists of fresh water, most of which is found in glaciers and ice caps, with a small percentage in rivers, lakes, and streams. The remaining 97% of the world's bodies of water is saltwater seas and oceans. While all bodies of salt water can be referred to as seas, technically a sea is different from an ocean because it is smaller and at least somewhat surrounded by land.
If I hurt myself and bleed a lot, can I run out of blood?
On average-sized adult has between 5 and 6 quarts, about 5 liters, of blood in his or her body. Larger people have more, and smaller people like children have less. The arteries, veins, and capillaries through which blood travels are so numerous and cover so vast an area that they would measure 60,000 miles, 96,500 kilometers, if laid out end to end. With all these blood vessels, then, the likelihood of injuring them is high. but blood contains special clotting elements that quickly take care of broken vessels, preventing any significant blood loss on the inside and the outside of the body. So your chances of running out of blood from a common injury are very, very low. And new blood is soon made to replace that which you have lost. But during a rare, serious accident in which a large artery is injured, the situation can be dangerous. Arteries carry oxygen-rich blood that is pumped away from the heart under strong pressure. When an artery is injured, then blood that runs through it doesn't have time to clot before it leaves the body. If a quart or more of blood is lost, a person goes into shock, a condition where blood circulation and other important body functions slow dangerously, leading to death in extreme cases. But if the injured person is close to a hospital, blood transfusions can be given, saving his or her life. Transfusions are collections of blood taken from healthy people, stored, and later used to help the injured and the sick.
How can this huge and heavy machine get off the ground in the first place? Let alone stay aloft for thousands of miles?
Airplanes function according to a complex mix of aerodynamic principles theories that explain the motion of air and the actions of bodies moving through that air. Airplanes get their power from engines. Small planes generally use piston engines, which turn propellers that push aircraft through the air in the same way that boat propellers push vessels through water. But bigger planes use jet engines, powered by burning fuel. These engines expel great amounts of air that thrust them forward and up. Airplanes are able to lift into the air and stay there because of the shape of their wings. An airplane wing is flat on the bottom and curved on the top. When a plane's engines push it forward, air divides to travel around its wings. The air that passes over the larger curved top moves faster than the air that passes under the flat bottom. The faster moving air on top becomes thinner and has lower pressure than the air below, which pushes the wing up. Uneven air pressure caused by the shape of an airplane's wings then creates a force called lift, which allows an aircraft to fly. The force of moving air is also used to steer an airplane. Steering is done through a system of movable flaps working much like boat rudders that are located on the plane's wings and tail. When set at an angle, they push at flowing air that pushes back, turning or tilting an airplane. To descend, for instance, a pilot lowers a plane's tail flaps, causing airflow to direct its nose downward. Turning requires changing the direction of wing flaps and the tail rudder. An airplane must be in constant motion, its wings slicing through rushing air to create lift in order to stay up. Moving air is also required to steer it. In other words, a plane cannot fly without the power of its engines thrusting it through the air. In order to get enough lift to rise into the air on takeoff, an airplane has to travel along the ground first at great speed.